I refer to this as an angled launch problem. The projectile started out at some initial height, but it didn't fall downward, so to speak. It was launched up at an angle and came back to the height from which it was thrown, launched, etc. Assume, unless you're told otherwise, that that's the case, that the projectile is coming back to the height from which it was launched. Like a soccer ball kicked on a field or a football that's thrown down the field, okay? I'm going to use a lot of facts from this motion map, which you have already drawn. First, the first most important thing, which is new compared to the horizontal launch, is you want to take this vector, this launch vector, this 11 meters per second, and you want to immediately change it, or at least change how you're looking at it. And you want to find Vx and Vy, and then we'll kind of discard the 11 meters per second, kind of. For our purposes, for this particular problem, we're not going to use the 11 meters per second. There are other problems where you might use that. But we're immediately going to break this down into horizontal and vertical components. And the Vx, and I'll write the angle in here, 30 degrees. It's important where that angle is. The Vx is equal to 11 times the cosine of 30, which I have calculated, and it's 9.526 meters per second. And as you've probably guessed, the V sub y is 11 times the sine of 30. It's a special right triangle, so some of you have already guessed what that is. It's 5.5 meters per second. And what we're going to do is I'm going to turn this into an organized list. Let's make this into an organized list. Let's keep these separate. Don't mix the x and y, except for, what's that one exception, class, that we do mix? Time. Good. So we're going to make a list of x's and y's here. And also start thinking about what else are we going to put in the x, what else are we going to put in the y. It's going to be hard to read, but I'm just going to shrink these more. This one's 5.5. This one's 9.5. And I've got my list of x's and my list of y's. Keep them separated. As a matter of habit, I always like to just write dx equals and t equals, because the only equation I'm ever going to use in the x is dx equals vx times time. Now, we don't even need that. We're not asked for it. I'm just saying it's a good habit to be in. It's a common question that you'll be asked, what's the range here? We won't actually do it, but it's a good habit. Acceleration in the y is always negative 9.8 meters per second squared. On the AP exam, you can use negative 10. Everything will work if you use negative 10. The v sub y should really be regarded as a v initial sub y, so this is going to be really small and sloppy, but I put a little o there. So what I'm pointing out to you is, this is small, this is sloppy, but right there I put an o, v initial y. V initial y, that's important. Because I'm about to write the v final y, think about that for a second. In the y direction, I know v final y, and it's 0. Because at the peak, this is tiny, but you saw that at the peak there is no vertical velocity. It doesn't stop, there's just no vertical velocity. And some of you are already seeing that, well, d sub y is what I want, because you want to find oh, I said rock, but really I meant baseball. I was cutting and pasting another problem, but the baseball. And you can see that you're going to use v final squared equals v initial squared plus 2ad looking at your knowns and unknowns, you know v final and the y, you know v initial, you know a, you're just trying to find d. And the maximum height, which is d sub y and occurs at the peak, I calculated earlier to be 1.54 meters. Which is just about Dad's throat height.